In this tutorial, I'm going to show you how to make two different types of materials. One is a dichroic material which produces an effect where the reflected light off an object is different color than the transmitted light. And the other material is an iridescent material where the reflected light off an object and the transmitted light through that object depends on the angle of incidence of the light, in this case the viewing angle of the camera. The dichroic material, the material that I'm using on this the four colored objects on the left side, is basically made by combining a glossy node with a refraction node at about a 50% level with a mix shader, and using a hue saturation value node to produce the color. And you feed the output of the hue saturation of the hue saturation node directly into the glossy shader, and then you feed the inverse of that color into the refraction shader. What this does is it produces an effect where wherever you have light reflected off the surface, you will see the main color, which in this case is green. And wherever it's dark and there is no refraction, where there is no reflection, you will see the transmitted color, which in this case is the opposite of green, which is magenta. This produces an interesting effect where the light reflected off the object is green. You can see kind of a green here, and the light transmitted through the object is purple. You see this effect a lot in certain types of jewelry and in certain types of mirrors and filters that are used for in telescopes and in lasers and actually in architectural designs. Large window panes, large pieces of glass are used with this material to create very colorful effects. The material is pretty simple. This is the setup here. I use a hue saturation value node because you can do different effects with this, where you can change the hue, the color of the material that you're using by varying the hue. And what you can do is what I'm using here is basically a 50% shade mix ratio for both. That way the sphere has at least some reflectance over the entire surface and some transmittance over the entire surface. That way the colors that you see depend on what you're reflecting. In this case, if you're reflecting something that's very bright, a very bright background, you're going to see mostly the reflected color. If you're reflecting a dark color, you're going to see mostly the transmitted color. You can control this if you want by using a layer weight node and using the facing output and setting the layer weight node to about 0.85. I wouldn't use anything less than this, otherwise you tend to restrict the reflection to a very small range and you don't get the full effect of the way the material is supposed to look. So anything above 0.5 is good. 0.5 to 0.85. 0.85 is usually what I use. That gives you a pretty uniform ratio from the edge to the center. But normally you would probably use this with about a 0.5 ratio. That we have a uniform amount of reflectance over the entire surface. The dichroic material can be used, you can use many different colors of the dichroic material in order to produce objects like this icosahedron, which has what did I use? 4 different colors that I use on this object, and each one of the faces has a different color. The only issue with this is that the colors from one face, the reflected colors from one face will interact with the transmitted color from another face, and vice versa. So you may not get as colorful an object as you think, because a lot of the colors, if the colors happen to be complementary, you'll end up getting white. In this case, you see there's mostly yellow here and green and red. It's not as colorful as I would have expected, considering that I'm using blue, green, red, and orange. So you might want to use just one color for the entire object. That produces a better effect, like you see in the sphere. This cube also has two colors on it, a blue and a red material. This face here is a red material, a red dichroic material, and this color here is a blue dichroic material. So you can see the blue reflected light and the yellow transmitted light, and here you can see the red reflected light and the green transmitted light. But if you look through it, you're going to see only the color from the front with some yellow transmitted light. So this is kind of a greenish yellow. If you look at it the other way, you get different combinations of the colors. The red and the blue here mixed together to produce a magenta color. So you can play around with that and see what looks good. One other thing you can do is that instead of using a layer weight node, you can use an effect where instead of using a layer weight node, you can use a combination of a geometry node and a vector math node. And what you want to do is you want to do the dot product of the normal with the incoming. Set the vector to dot product and use this instead of the layer weight node. What I found is that this produces a better effect. Let me change this to, I think that's red. Yeah, red. This produces an effect similar to the layer weight node, but it gives you more control over exactly what's going on with the transition between the two colors. Here the transmission, what this does is essentially produces the transition goes from, in this case, full reflectance to zero reflectance at the edge. Now this you probably want to reverse it so that you see the transmitted color in the middle and the reflected color around the edge. And you can add a multiply node here. You can add a math node here, and if you choose this to multiply, you can control the rate at which the transition happens. In this case, you have pretty much full reflectance up to about the halfway point, and then the transmittance comes in. You can change this to, if you do the 2, the opposite happens. The transition to full transmittance happens very rapidly. You can then add another node to this. You can add another math node to here and set this to add, or actually set it to minus 0.05. And what this will do is it will give you at least, and set those clamp. What this does, by adding this 0.05 to it, is it gives you at least 0.05 glossiness over the entire object. So there will always be some amount of glossiness. You can always change this, negative 0.1, so you get a little bit more glossiness. You can turn this down to 1.2 so that the transition is so rapid. So this gives you a little bit more control over how the transition works than the layer weight node. The layer weight node has this blending factor, which I am not entirely sure exactly how this blending works. I know it controls the blend, but it doesn't tell you what function they're using to produce the values that are used to control the mix shader. So this gives you a little bit more flexibility. Now, for the iridescent material, what I've done is, in the iridescent material, if it would select this, okay. For the iridescent material, I use the setup that I just showed you, where instead of using a layer weight node, I use a dot product and the geometry node. And I use that to control the hue of the color. So instead of being a constant color like in the dichroic material in this sphere here, what I do is I change the color with respect as the angle of the viewing angle changes. So here what you have is you have red at the very edge, and then transitioning all the way to what would be, get rid of this, what would be magenta, what is magenta in the middle. And this effect works very well for objects that are works very well for objects that are very complicated, like this blob here, where different parts of the object will have different colors. You can see here there's yellow over here, there's red there, there's purple here, blue. You can change the transition this by changing, in this case I'm using a power node where I'm raising the output of the dot product to some power. A value of 2 stretches the compresses the rate of the transition so it happens more rapidly, and so the colors change more rapidly. If you use something like 0.5, it stretches the colors out so there's less colors. You can, you could replace this with a multiply. You can do the same thing with multiply. If you multiply by 0.5, you get a smaller range of colors. If you multiply by 2, you get a more rapid range of colors. The transition happens a lot more quickly, and it happens very close to the edge because of the way the view angle works. So you don't want to make this too big, or the transition happens very rapidly and it's kind of hard to see. With this material, you probably do want to use a layer weight node with the facing set to about 0.85 so that you can see the transmitted color through the object. Otherwise, you will not see this color except as an interaction with the reflection. If I don't have this here, you can see that there's like this general green color here that seems to be on top of the reflected color. Well, that's because I've got 50-50 for the mix ratio here. And so this kind of tends to interact. You're seeing what you're seeing is the green colors from the light that's transmitted through the object. In this case, there's magenta here, so you're going to see green here, and this tends to kind of interfere with the color, with the reflected color. If you want it to be completely reflected, then you just crank crank up the mix ratio to 100%. And you won't see any transmitted color at all, and you'll just have the object, the reflected color, which changes with the viewing angle. So you can see right at the edge of the material, you're going to see, in this case, red, and in the center you're going to see magenta. So you're seeing the full range of colors. If you multiply this by, is that 0.5? It reduces the range of colors. You can see that here. So this also produces a nice effect. I think it looks better I think the iridescent effect looks better if you have a high amount of mostly reflectance. If you let too much of the background color of the transmitted color through, then it starts to interfere with the reflected color. So it's probably better to have it around 0.5 or higher, depending on the color that you're using. So, or use the facing output of a layer weight node to control that, so that you right at the edge you see full reflectance and some of the transmitted color gets through in the center. If you use an add node to mix the colors, then the colors in the middle start to look white, because now you're getting the complementary colors adding together, and when you add complementary colors, you get white. So the add node really isn't the good choice for that. You want to stick with the mix node so that you can control the amount of mixing that you're using. The iridescent effect is more visible here on an object with flat surfaces, as the angle of the faces changes with respect to the object. You get different colors. This face here is looking straight at the camera, and because I'm using the layer weight node to control the mixing, at least here you get to see the color that's being transmitted through the object. Here with this cube, you can see that the top is very reflective and is reflecting the environment, but as I change it, the color changes. So here it goes from being red to magenta to yellow to whatever blue is. Blue's probably somewhere over. There's blue there. So you can see how the objects change as the viewing angle changes. This sphere here is made by taking the same setup as the dichroic material, except what I'm doing is I'm choosing the color using a Voronoi texture set to cells, and I'm multiplying it by 3 to increase the range of the colors. And in this case, the color is constant. It does not change with the viewing angle. The reason these colors are changing is because the color on one side of the sphere is interacting with the color on the other side of the sphere, and so it causes that color change to take place. And again, with this one, you also want to use a layer weight node so that at least some of the transmitted color passes through the center of the object, and you have full reflectance around the edge, so that there you actually see the reflected color rather than the transmitted color. You could also replace this with an iridescent effect, but the problem is that you're using the iridescence to determine the color, and there really is no way to get the Voronoi texture in there unless you multiply the two. I mean, you could feed the Voronoi texture into a multiply mode, multiply it times what was it? What would it be if I put a geometry node here, put a geometry node there, and a vector, come on, vector math node here, normal to there, incoming to there, set it to dot product, then take this value and multiply it times that. And so now what you're getting is the Voronoi texture and the iridescent effect working together, I guess, and it causes the color to change as the viewing angle changes and also produces the cellular effect. So you can combine all these effects to get different things, to get different results and get the object to look the way you want. You can also use this node setup for just a regular sphere with refraction and gloss, because it gives you I think it gives you a little bit more control over the the way the mixing is done. So here I've got it set up so that you've got at least 0.05 gloss over the entire surface, and then a pretty quick transition from the edge to glossiness at the very edge. So if I turn this value up, the glossiness gets closer to the edge, but with this 0.05, this minus 0.05 here, I always have at least 0.05 glossiness over the entire surface. You want to make sure these are set to clamp, because you want these values to be 0 to 1. So yeah, if large values reduce the range of the glossiness, and large values reduce the range of the glossiness, small values increase it, as you can see here. So now you've got a lot more glossiness, and I think this probably I think this works better than the layer weight node, because at least here you have a little bit more control. You can actually you can change this to a power, to whatever combination you want. You can have it set up so that you have actual rings of reflectance and transmittance. Instead of being a uniform transition, you can have it be, reflectance, glossiness here, then transmittance, then glossiness, and transmittance. So there's a lot of things that you can fiddle around with in order to get that result. So this produces a pretty good effect that actually mimics very well how the actual iridescent materials and dichroic materials work.